So here's a more challenging addition of rational functions. Instead of 2, we're looking at 3 of them. So we have to work with 3 expressions pretty much simultaneously. So we're going to start off with just factoring the denominators. And luckily our numerators are pretty simple monomial terms. So my first denominator is a simple trinomial. I'm looking for 2 numbers. They add to give me -6, multiply to give me +9. Those numbers are -3 and -3. Minus, same numerator, over, once again, we have a simple trinomial, 2 numbers that add to give us 2, multiply to give us -15. Those numbers are +5 and -3. Finally, our last fraction, same numerator, and the denominator in this case looks like a difference of squares. So I know it's going to be x minus 5 and x plus 5. So now we're at the point where we have to find a common denominator. And we have 3 denominators we need to deal with. Now, the first fraction has an x minus 3 twice, but does not have an x plus 5, does not have an x minus 5. So guess what? I'm going to rewrite that fraction such that I multiply numerator and denominator by x plus 5 and x minus 5. And to make it explicit, I'm even going to use a different color. So let me extend that fraction line. So I have an x plus 5 and an x minus 5. Same thing here in the denominator, x plus 5 and x minus 5. And then I am subtracting this next fraction, which we'll talk about in a sec as well. So let me just copy that, paste that here. Now this fraction is missing in the denominator. I mean, it has an x plus 5 term, has an x minus 3, but it needs 2 x minus 3 terms because this one has 2, and it also needs an x plus 5 term. So I'm going to multiply the top and bottom of this second fraction, and again I'll use a blue color to indicate it, by x minus 3 and x minus 5. So x minus 3 here and x minus 5. So this is getting pretty long, but unfortunately this is how it works out. Final term, I'm going to copy that, place it here. Now this fraction, if we look closely at the line above, it has an x minus 5, it has an x plus 5. However, it's missing an x minus 3, it's missing 2 of them. And that's what we're going to multiply top and bottom of this fraction by. X minus 3 and x minus 3. So going over here, we're going to extend this line, and I'll put x minus 3, x minus 3. If I wanted to, I could have written x minus 3 squared, but I just want to make these factors explicit. So, very unwieldy set of rational expressions. At this point, it's probably wise to just state the restrictions. So one at a time. Let's look at our first set of denominators. Well, actually, at this point, the restrictions in one denominator are the restrictions for the entire expression because they have the same denominators. So here, I'll notice that x cannot be equal to +3. No need for the plus sign. And x cannot be equal to plus or minus 5. And that comes from these 2 guys here. So those are our restrictions. I'm going to just polish it up, take these and put them to the side for now. And I think at this point we're ready to start simplifying our numerators. So my first numerator, I'm going to multiply the 2 in. Actually, I'm going to combine these together because working backwards, I recognize that's a difference of squares. I get x squared minus 25 minus close bracket. So the 3 goes here. Actually, I'm going to multiply these denominators together first. I'm going to multiply these binomials together. So I get x squared minus 8x and plus 15. And finally, plus x in bracket, x squared minus 6x plus 9. This last expression just came from multiplying these two binomials together. It's a perfect square trinomial. And all of this stuff is written over a common denominator of x minus 3, x minus 3, x plus 5, x minus 5. Okay, things are tidying up. I think we have to continue our distributive action here. I'm going to bring this 2x in. The 3x will come in as well, and the positive x will come in as well. All three terms. So let's see what we get one at a time. So here I have 2x cubed minus 50x. Then I have negative 3x squared plus 24x minus 45. Continuing, the x and the x squared gives me x cubed minus 6x squared plus 9x. And before I simplify that, I'll just write this over a common denominator, which is all this stuff here. And I'm almost done at this point. My final expression is I'm going to collect the like terms here. So I have this 2x cubed and the x cubed. That'll give me 3x cubed. I have the negative 3x squared. The negative 6x squared will give me negative 9x squared. And then I have the 50 plus 24 plus 9 gives me negative 17x. And finally I have minus 45, which is the last term here. And this is all over my same common denominator. So I think that's it. There's no other simplification we can do. If you wanted, I mean, you could multiply out the denominator, but I think leaving it in factored form is ideal. Put the restrictions where you want. And that's about it.